In this video, we are going to unify all the physical dimensions like mass, length, and time into one scale. You may wonder, how is it possible to unify these three dimensions, having different values and different units in physics? The unification of dimensions is the only way to reach the theory of everything and quantum gravity we have been seeking for so long. In mathematics, we can define all the dimensions of a physical object on the same scale. All three dimensions of height, length, and width are mathematically unified on the same scale. In mathematics, all three dimensions are unified within an object itself. Imagine a square-shaped object. All its dimensions are within that square. But in physics, the same object has only one dimension of mass within it. Time and length or space seem to be separated from the object. Fortunately, time and length or space are unified as spacetime by Albert Einstein in his theory. But we still measure them on two different scales. Here, space and time are coordinated within the object and measured on the same scale. This concept is extended in terms of Planck units. We know that the Planck units are derived from the universal constants c, g, and h. Here c represents the velocity of light at vacuum, g represents the universal gravitational constant, and h represents the Planck constant. The Planck units, which are representing the distance as Planck length, L rho, time as Planck time, T rho, and mass as the Planck mass, m rho. These three units are the smallest known fundamental units that we can see in particle physics and quantum mechanics. I wish to start thinking from here. According to these units, we have already calculated the Planck energy, volume, area, and so on. So Planck energy can be defined as E rho equals square root of hc raised to 5 divided by g. Here I want to describe the micro-universe and the visible universe alike. So by equivalency principle, we can write as E rho equals m rho c square. Here, the speed of light c we can define as L rho divided by T rho. The speed of light does not change even if described in Planck units. So we can rewrite the above equation in a way that we can understand more. Now we can see the three basic dimensions of the universe in this equation. E rho equals m rho into L rho divided by T rho the whole square. This is the equation for Planck energy. When I am looking at this equation, I can realize that this is the smallest amount of energy possible, and it is the result of the interaction between the three fundamental Planck units: length, mass, and time. In this equation, we can see the quantized states of Planck units. We can explain this situation through dimensional analysis of a geometric system. I am explaining this geometry in the below of this theory. So the Planck energy is the particular combination of Planck mass, Planck length, and Planck time. I consider this particular state of energy to be a closed system. It is the smallest form of energy, but not the last, so it can add more energy. If we add the x amount of energy to it, the equation will continue as follows. X E rho equals x m rho into L rho divided by T rho the whole square. I know that all the above equations are familiar in physics, but my understandings or point of view on these equations are allowing me to create a strange idea. Here I am adding the x amount of Planck mass on a system, at the same time have to add the same amount of Planck length and Planck time to the system to fulfill its requirements as energy. We can found that the value of x into L rho divided by T rho is always constant and represents the speed of light. Now, this system has the ability to grow up by adding more energy in it and can become as a particle or a large size. The only thing we have to notice here is, the presence of more Planck energy or Planck mass in a system will allow it to accommodate the more units of Planck length and Planck time in it. So no matter how much energy a system has, it can be represented on a Planck scale. When we are considering any form of energy as a system, we have to consider also the Planck length and Planck time as a source of energy. In this case, I would like to say that these three Planck units represent some source of energy. Also, We know that everything in the universe is under the influence of a universal gravitational constant. So let us write this equation as follows. Gxe rho equals Gxm rho into L rho divided by T rho the whole square. Now we have the idea of any quantity of energy in the Planck scale. Energy must be permanent in the system with its dimensions. We can never imagine any type of matter in a two-dimensional shape, so I consider that the system will create a three-dimensional shape itself. If a system creates itself a three-dimensional shape, it must have a volume. And here we are coming with the idea of Planck volume to accommodate Planck energy because these two are the smallest known units on the same scale. Naturally, we can claim that unit Planck energy will be perfectly fit in a unit Planck volume. Mathematically we can represent this situation as E rho equals V rho. Here Planck volume is square root of hg the whole cube divided by c raised to 9. So, square root of hc raised to 5 divided by g equals square root of hg the whole cube divided by c raised to 9. Here both sides of the equation are representing two different things. The left side of the equation represents energy and the right side represents volume. Right now both sides of this equation are dimensionally not matching. Dimensional analysis of this equation tells us both sides of the equation represent different situations of a system. The dimension of the left side is L square mt raised to -2 and the right side is L cube. This will never validate an equation. So if we can represent the left side of the equation with respect to L in quantized values of Planck mass m rho and Planck time t rho with respect to Planck length e rho, we can write both sides as volume. The quantized Planck mass with respect to Planck length will represent as m rho and accordingly, Planck time will be t rho. For the theory of everything to be complete, which we are still seeking, unification of dimensions must be possible. In mathematics, we have unified these dimensions. If we take a physical object, mathematically it has three dimensions. We call it length, width, and height. We measure all three dimensions on the same scale. We categorize dimensions in physics as mass, length, and time. All these three are measured on three different scales. We can unify these three dimensions. Here I am going to bring a picture to a better understanding. In this figure, the space or distance and the time are equally distributed. If we measure the strength of time and space inside this system, we can see that both are distributed in the same strength. So we can say that time is equal to space or distance. Distribution of time we can call Ts and distribution of space as Ls. Ts equals Ls. Now we can bring the equation E rho equals V rho and its dimensional analysis here. The Planck energy E rho is perfectly fit in a Planck volume V rho. It will not allow any empty space in it. The dimension of the left side is L square mt raised to -2 and the right side is L cube. Now we can import the strength of each dimension in this equation. But we still have to find the strength of mass ms. Ls square ms. Ts raised to -2 is equal to Ls cube. We can say that the value of Ls and Ts are the same but in opposite directions. Now we can easily find out the value of ms. Ms is equal to Ls cube. So this time we can complete the equation as Ls square ms cube Ts raised to -2 is equal to Ls cube. The left side of this equation clearly declares that it can create a space that is equal to the right side of the equation. Therefore the increasing energy in the system will increase the volume by the same amount. We can state it as follows. X into square root of hc raised to 5 divided by g equals x into square root of hg the whole cube divided by c raised to 9. Here we consider all these three dimensions as sources of energy. Therefore, the quantized value of these represents the strength of its energy. So the quantized values of these three dimensions are the same always. Now m rho and t rho are having the same dimension of L. In this case, the combination of these three dimensions in a particular mode indicates that the volume of the system or that the system is quantized by energy. We can also avoid all these steps by considering the dimensions as it is. But here I am interested to say that all these three dimensions are closely related. The picture below will explain more about this concept. This picture shows us how energy at the Planck scale is obtaining its space in the unit Planck volume. We can explain this picture in two different ways. The first way, we can say that energy is equal to the volume. Unit amount of energy can represent in unit volume, which I was explained in the above equation E rho equals V rho. The next is by considering all these three fundamental dimensions as equal strengths. It is possible when they are quantized, and we can experience that in the case of energy. Here Planck length, Planck mass, and Planck time are in a quantized state. The above equation is representing the relationship between energy and volume and is strictly at the Planck scale. It is very important to describe the gravity of a system. Now we can apply this equation to an atom. But we already know that an atom has its own volume. The problem here is that there is a lot of free space within the atom. So we must have to determine its volume at the Planck scale to describe its gravity. This volume represents the actual volume of energy. It does not allow any free space inside the system. For example, suppose we fill some air in a balloon. Naturally, that balloon will create a gravitational field. Suppose we do not release the air in the balloon but make it a little smaller by applying a force on it. It still has no change in its gravitational field because there is no change in the amount of energy inside it. But its surface is closer to its center, so the gravitational force felt on the surface now will be greater than ever. This is an explanation of Newton's theory of gravity. All of these are well explained in the book Key to the Secrets of the Universe. That is a simple book written in a way that everybody can understand the whole universe. There we are explaining the universe from the beginning stage. We start from the primordial coalition of two primary particles to form the Big Bang singularity. Also, we are discussing many other issues in physics in the book. Or you can watch our videos for more information. All the links are in the description box. You can see these things on our website. Let us now consider this in the language of the general relativity theory. Gravity in the language of the general theory of relativity is the curvature that energy creates at the spacetime, where it is located. Let's see how it is. We already know that energy needs spacetime to exist. Let's see how it curves spacetime. Let's go back to our balloon. Let us assume that it is already located in spacetime. Hence, its surface is in continuous contact with spacetime. If its size suddenly decreases, spacetime will be drawn to the balloon's surface for its survival. An emptiness between the balloon and spacetime is not possible. Now you may think that spacetime itself is empty. But not so. Spacetime is just as important as energy. General relativity theory is describing the relation between spacetime and energy. The theory of relativity describes gravity as the curvature of spacetime created by energy. Let's go back to our balloon itself to figure out how. Suppose we refill the balloon without changing its diameter. We know that it is not possible. The balloon expands as we fill the air in it. But let us think like the above. As the air fills up, so does increase the amount of energy inside it, and so does its gravity. This is exactly what Newton and Einstein described. According to the theory of relativity, as gravity increases, it must distort more spacetime. As the amount of energy increases, it will influence more spacetime. This will put more pressure on spacetime. Naturally, this pressure is felt most in the area adjacent to the surface of the balloon. This is what we see in black holes. The spacetime is so compressed that even light cannot escape. A certain amount of energy will influence a certain amount of spacetime. This is what the theory of relativity tells us. Here we can see the change in the free space inside the balloon. Similarly, increasing the diameter of the balloon while retaining the same energy will change the curvature it creates in spacetime. It then absorbs the same spacetime into the balloon and reduces the curvature of spacetime. Here there is no change in the amount of spacetime adjacent to the balloon. Here the gravity of the balloon does not change. The balloon will still have the same influence as it did in the same spacetime away from its center. So the size of an atom or a large object plays no role in its gravitational field, and the Planck scale volume determines the gravity of the system in relation to the total energy of the system. When we are considering this situation, E rho equals V rho, the quantized Planck mass, m rho, and Planck time, T rho, are having the same dimension as the quantized Planck length, L rho. It is an idea which states the combination of the three basic units, quantized state, will be equal to the Planck volume. So I can say that all these three Planck units can also be represented as fundamental dimensions like length, breadth, and height. It is the key idea of this theory. So the energy can be represented in a single unit when all these three basic units are in a quantized state. Up to now, I was thinking about energy at the Planck scale. Now I am intended to think about the fundamental properties of energy at the Planck scale and its reasons. When you think of the smallest units possible, it seems very easy to create ideas. At this stage, we can only have the smallest amount of energy, and spacetime where it accommodates. Of course, we cannot ignore the presence of a universal gravitational constant. As a start, let us for a moment forget the existence of a universal gravitational constant. For me, energy is something that is always active. I would like to say that consciousness is one of the fundamental properties of energy. Energy has a life on its own, or it can be a source of life. This is the only reason for the presence of life on our planet. Therefore, the probability of the existence of life occurring in many other parts of the universe is huge. With this idea, we can explain the evolutionary dynamics of energy in the universe. Now let us try to understand more about the other properties of energy. We find that the energy is in a very limited space with Planck volume that is self-sustaining there, so things usually end here. But energy is conscious by itself, so things are starting from here. We can consider the unit Planck energy at the unit Planck volume as a system. When the self-conscious energy tries to confine itself to its confined spacetime, the result of the work done by this will spread to outer spacetime. This amazing phenomenon we call gravity. This is the same thing that Sir Isaac Newton called the gravitational force of an object. This is the same phenomenon that, according to Albert Einstein's ideas, extends to spacetime and influences the curvature of spacetime. This effect allows energy to stay in spacetime and allows the curvature of spacetime to be created. This is the same thing that leads to the evolution of our universe. So the amount of energy in a system is the reason for gravity. Any amount of energy can create gravity, and it is one of the fundamental properties of energy. Mass is just a dimension of energy, like the length and time. This is why we claim that a photon has no mass but can interact with gravity. This idea can resolve the puzzles of dark matter and dark energy. For this reason, I am considering energy as a combination of three fundamental dimensions. We can unify these three units with the three fundamental dimensions like length, breadth, and height with Planck length, Planck time, and Planck mass. We can define gravity in a simple way, as the result of the work done by unit energy in unit volume at the Planck scale. M rho into L rho divided by T rho the whole square into V rho equals S rho. This equation states that the product of energy and volume at the Planck scale is creating the Planck spacetime, S rho. This equation is giving us the idea of Planck spacetime concerning the Planck energy, but I am looking for an equation that relates the spacetime with the dimensions of volume. So volume is calculated as a form of energy as I described in the above equations. This equation can be represented as follows. V rho into V rho equals V rho square. Or S rho equals V rho square. These equations represent the spacetime that a unit Planck energy can create. We can also say that v rho square is the amount of spacetime in which a unit Planck energy can create a curvature. So from here, we can see that the gravity of unit energy can only affect a fixed spacetime. It can create a curvature of spacetime at a limited volume. Hence I can say that gravity of any amount of energy has a limited range, and I cannot say that gravity can make effects in an infinite range. Of course, everything in the universe is under the influence of universal gravity. That's why we are allowing universal gravitational constant g in our equations for gravity. It doesn't mean that gravity of a system has an infinite range. I can never believe that a steel ball of 1 kilogram has an infinite range of gravity. So, g into s rho equals g into v rho square. To explain more about gravity and other properties of energy, dimensions of the system need to be discussed. We know that particles are showing different properties like different spin, different charges, and all. To realize the reason for these properties, we must have to know more about the dimensions. Dimensional variations can determine the basic properties of a particle. It is a simple idea, but if we elaborate on it, this idea is applicable in a wide range. We are living in a three-dimensional universe, but the general theory of relativity is suggesting spacetime as the fourth dimension. Many other theories argue that the universe has even more dimensions. I am considering it as a spatial dimension, that occurs when matter projects its effects on spacetime. The universe is actually a state in which three-dimensional matter is located in spacetime. I like to believe that we live in such a three-dimensional universe. Matter is located in spacetime. So we are keeping spacetime as the fourth dimension. In this part, I am discussing the three dimensions of a closed system, where the unit Planck energy is accommodated. So, I am interested in working with three dimensions because matter can only have three dimensions. It can neither shrink to a two-dimension nor achieve the fourth dimension. Three dimensions are a basic property of matter or energy. We may discuss the spatial dimensions later when we are trying to understand more about gravity. It is not necessary to discuss more the spatial dimensions, because we already have a successful theory of gravity by Albert Einstein, which explains the dimensions of spacetime. Here I am about to describe how these three dimensions, length, breadth, and height, are playing a crucial role to determine the basic properties of matter. We can insert the quantized length, mass, and time at the Planck scale into these three dimensions. To explain my ideas, I am starting with a two-dimensional shape. My idea is to get a life with a simple thought experiment. It is familiar in mathematics, and I am going to elaborate this idea into the dimensional properties of matter when we can consider it as a system. And we know that we have mass, length, and time in the system. Let us try to unify these three fundamental units with the three fundamental dimensions. I can explain it with the help of a picture. I think it will be more helpful to understand the idea perfectly. This is the best idea to describe the nature of gravity in different situations. We can analyze how gravity gets changes according to the changes in the dimensions inside the system. Also, this idea is the only helpful clue to describe the nature of a system. This picture will help you to understand more. Imagine that I have a square with a fixed length and area. This is a two-dimensional shape, and we can make changes on one of its dimensions, by keeping the area the same, as shown in the picture. Here we have the length and breadth as the two dimensions. This figure shows the different situations that occur when this square has differences in its dimensions. At the initial stage, it was a perfect square. Then gradually it changes one of its dimensions and it becomes a rectangle. And it continues this process, and the dimension is forced to undergo a reverse process, to become a square again. After reaching a certain point, it is unable to keep its volume the same, so it is forced to change its characters and becomes a square in the opposite direction. This picture is just an example. It can change its dimensions from left to right or upward to downward and vice versa. So here the actual nature of the shape is varying while the rate of change in dimension keeps the same direction. Here I am replacing these two dimensions into the basic units of length and time, with the help of the above-mentioned statements of this chapter. Now, this two-dimensional shape becomes the measurements of time and length. So while calculating velocity, according to the path of its dimensional part of the length, we can create an arbitrary two-dimensional shape. This situation is important to explain the nature of energy in phases with different dimensions. The same idea is applicable in three-dimensional shapes, so we can apply this to the volume of a three-dimensional shape. We can observe the same process by importing this idea into a three-dimensional shape. We are applying the same methods here, so it is not necessary to explain more about the applications of this idea in a three-dimensional shape. By changing any of its dimensions, we can change the characteristics of the shape. What we are interested in three-dimensional shape is that matter can be accommodated in a three-dimensional space only. The only thing we need to look at is to keep the volume the same. If we consider it as a system, we can analyze the changes happening to the system. Now we can import the concept of mass, time, and length into this system. It would be easier if we imagine these units on the Planck scale. By changing these units or dimensions in this system upon the same volume, we can experience the changes in its basic characters. By accepting time, length, and mass as a source of energy, the total system will experience different natures upon changes in any of these sources. If we make changes to any one dimension, it will affect the volume of the system. In this way, we cannot keep the volume of the system the same. Always we must have to make changes to any two of these three dimensions. The mass is not changeable, so we can only adjust the space and time. So we can call it a dimensional adjustment. This idea will change our present concepts about energy and the universe itself. I would like to use the same idea to explain gravity. The here picture will give us more explanations. This picture explains my ideas about gravity. The inner circle in this picture, E rho equals V rho, represents the unit Planck energy and at the Planck volume. So this is the smallest possible space in which energy can get accommodated. The lines inside the inner circle m rho and L rho represents the quantized Planck mass and Planck length accordingly. The line CD represents the quantized Planck time t rho, and I have placed it at this position in this picture, to get a more convincing understanding of the dimensional changes. The outermost circle GS rho equals G into V rho square, represents the total curved spacetime by unit energy, or the volume of the curved spacetime. The point O represents the dimensional change position. The arbitrary triangle BAC represents the distribution of space, and the arbitrary triangle DCA represents the distribution of time accordingly. Here we can see the distribution of time and space are in opposite directions. Line AC is the radius of the total gravitational field of the system. I am going to explain how gravity is created by a unit volume of energy and how the dimensional changes will affect its fields. It is not necessary to explain the curvature of spacetime here. We just need to check how this theory interacts with the general theory of relativity. Gravity is the influence exerted on spacetime as a result of the work done by a unit of Planck energy per unit Planck volume. It can make a curvature on a fixed volume of spacetime in accordance with its dimensional shape. If I repeat it with respect to Newtonian gravity, I can say that it will create a fixed force field in space to interact with other forms of energy. In this picture, we can see that the gravitational field is divided into two sections at a point O. This is an imaginary point where the gravitational fields get reversed. To get a better idea, I wish to divide this into two parts like x and y. M rho into L rho divided by T rho the whole square into V rho G the whole divided by 2 into x plus M rho into L rho divided by T rho the whole square into V rho G the whole divided by 2 into y equals GS rho. Or we can say V rho square into G the whole divided by 2 into x plus V rho square into G the whole divided by 2 into y equals GV rho square. In other way, m rho into L rho divided by T rho the whole square into V rho G the whole divided by 2 into X plus m rho into L rho divided by T rho the whole square into V rho G the whole divided by 2 into Y equals V rho square into G the whole divided by 2 into X plus V rho square into G the whole divided by 2 into Y. The first part represents the space-dependent field and the second part represents the time-dependent field. So imagine that the first section contains a field with x distance of its radius, and the second section contains a field with y distance of its radius. These two values of x and y can create its own volume in the curved spacetime, and the sum of these two volumes will be the actual curved spacetime. Here we can imagine that space and time are distributed uniformly at each distance of this field. The picture shows us that they are distributing with opposite directions. It is already proved by Sir Isaac Newton and Albert Einstein in the theories of gravity. So we can see that the strength of the spatial field is decreasing from the center of the system and it will be zero at the end of the curved spacetime. Same like, the strength of the time field will decrease from the starting point of the curved spacetime and it will be zero at the center of the system. Increasing the volume of the field will decrease the strength of gravity. So the distribution of the spatial field near the center will be high because the volume of the field here is very small. This is the general idea of a gravitational field and the gravitational strength of a system. I have not mentioned any tensor fields in this equation because here I am describing the strength of the gravitational field of an individual system. When we consider the influence of an external field, we must have to apply different variations depending upon the influencing fields. Now we will look how the dimensional dance will affect the strength of the gravitational fields at each level. I can clearly state that the configuration of dimensions in a system will directly affect the strength of the gravitational field of the system. The volume of the gravitational field or the curved spacetime must always be the same, even if it changes its dimensional configurations. I have explained above that the system is a combination of three dimensions. So if it makes any changes in any two dimensions, it will affect the strength of the field. As per the picture, if we increase the dimensional values of the space, the system must have to reduce the dimensional values of the time. This situation will increase the strength of the spatial field inside the curved spacetime, which will tend to reduce the strength of the time field. So, by changing the configuration of dimensions, a mass can show different strengths of gravitational fields. If the Earth has another dimensional configuration, we will experience a different gravitational strength. Here I am introducing a new idea to determine the strength of the gravitational field at different stages. It states that gravity has a finite range. What we are experiencing in the Earth's gravity is one of its possible dimensional configuration states. The dimensional configuration of a system can determine the basic nature of the system. In physics, we are studying a lot of particles. We also discuss the possibilities of many particles that we do not yet know. We know that they are all made of energy. But each of them has different characteristics. The main reason for all this is the dimensional configurations of those particles. This dimensional configuration can explain the evolution of the universe by accepting that energy is self-conscious. By accepting that energy itself can be a form of life, we can state that the universe was created by itself. The probability of the existence of life in any part of the universe is very high. This theory can generate very valuable information related to dark energy and dark matter. In the next chapter, I am trying to describe how gravity is working in a curved spacetime, or how it is interacting with the curved spacetime of another system. Those things are well explained in the theory of general relativity already. We are trying to create more about it from our point of view. All these are the results of our researches. Aquilon is an individual research firm based in Japan. We focus on the theory of everything. Also, we create fascinating ideas to accelerate the technological growth of Type 1 civilization. We are creating favorable conditions for human society to enter the next stage of evolution. In all of our videos, you can find some interesting new ideas. You can see these things on our website. Thank you for watching our video.